Hi everybody, this is the final topic for Chapter 8. It's Topic 7, Modeling Quadratic Equations in Word Problems. So we're given the equation negative 16t squared plus vt plus s. Here's what each variable represents. So the h of t is just like h equals. It's height in terms of time, so h of t is the height, where t is time, usually in seconds. Then we have the letter v, which stands for velocity, and s, which is the starting height. So we'll always be given the velocity and starting height, and then solving for time, because we're going to be doing problems where the height is going to be 0. So let's look at this first problem. A rock is dropped from a riverbank that's 4 feet above the surface of the river. Because the rock is dropped, there's no velocity, because it's just being dropped vertically. There's no power behind it. It's not being thrown. So that's why the velocity is going to be 0. Then it's 4 feet above the surface of the river. That's our starting height, so s is equal to 4. The question wants to know after how many seconds does the rock hit the surface of the water. That means we want the height, which is h, or h of t, equal to 0. So let's plug in all the information we know. And again, we're never going to get a value for t, because we'll always be solving for t. So 0 equals, because we're plugging in 0 for h of t, and then continue to write the equation above. Negative 16t squared, that's already given. Here's a plug-in, v. We know v is 0, so plus 0t, and then plus s, our starting height, which is 4. So again, because our velocity is 0, I'm just going to get rid of it and write negative 16t squared plus 4, because that's going to be easier for us to solve. So when I look at this problem, I know I could take out a GCF of 4, but that doesn't really help much. I mean, I'm going to divide everything by 4 just to get it down to smaller numbers, but as far as factoring negative 4t squared plus 1, it's a little unfamiliar, but if I swap the order, it's going to be difference of squares, where 1 is a perfect square, 4t squared is a perfect square, separated by a minus sign, so we can use difference of squares. Alright, so the square root of 1 is 1. The square root of 4t squared is 2t, and always opposite signs in between. So we can set each of those sets of parentheses equal to 0 and solve. So we get t is equal to negative 0.5 and positive 0.5. However, having negative 0.5 seconds doesn't make sense. So our solution is t equals 0.5 seconds. Again, anytime you get time is equal to 0 or a negative number, you can just throw it away. Next question, we got a football thrown in the air at an initial height of 5 feet. Initial height is the same as starting height, which is s. So s is 5. This time we are given a velocity of 16 feet per second. That is our v value. The question wants to know, when does it hit the ground? Ground level is 0. 0 feet. So we have all we need. Let's plug it in. Plug in 0 for h. Negative 16t squared will always stay the same. And our velocity is 16, so 16 for v, and our starting height is 5, so 5 for our s. Alright, so right now, I'm looking for a GCF. There is not one. When we factor using the box method, we always want our square term to be positive, so I'm just going to divide or multiply every single thing in the equation by negative 1, so I'm just going to change those signs. So we get positive 16t squared, negative 16t, and negative 5. Let's go ahead and do the box method. Our magic number is negative 80, so the winning pairs are negative 20 and positive 4. Let's factor out the GCF left and up, and there are our factors. Again, this part is not new, so I'm going a little quick, but we already know how to do this. Set each of them equal to 0 and solve. Again, I can throw out any negative values, so that means my solution is 1.25 seconds when I solve that first equation. Alright, our last problem we're going to go over, we got student council wanting to purchase a table. So this time we're not going to use that negative 16t squared plus vt plus s. That's actually only on this slide for the U-try. The table comes in a variety of dimensions, but for every table the length is 1 meter greater than twice the width. I'm going to go ahead and draw a table. If the length is 1 meter greater than twice the width, we can just label the width, and then the length is going to be 2 times that value plus 1, so 2 times w plus 1. And because it's a rectangle, opposite sides are equal. Now, it tells us they've budgeted for an area of exactly 3 square meters. So, we have a length, we have a width, and area is equal to length times width. Area is 3, the width times the length, w times 2w plus 1. So in order to solve this, we have to get 0 on one side. I'm going to distribute first. Either way, it doesn't matter. So I get 2w squared plus w, and then I'll subtract the 3 over so I can get 0 on one side. Once again, just like the previous problem, there is no GCF to divide by, so I have to use the box method since my leading coefficient is 2. It's not equal to 1. So first term, last term, magic number is -6. Factors of -6 that add to +1 are 3 and -2. Alright, you guys know what to do from here. Factor left, factor up. And I can write them, set them equal to 0. Since it's factored, I'm going to take w minus 1 and set it equal to 0, and 2w minus 3, or 2w plus 3, sorry, and set that equal to 0. I get a width of 1 and a width of -1.5. So obviously you can't have a negative dimension for a table. I'm going to throw that away and choose the 1. So if the width is 1, we plug in 1 for w, so that means the length is going to be 3. 2 times 1 plus 1. So the dimensions 1 by 3 meters. Right, go ahead and do the U-try. Don't forget to use the vertical motion model at the top of this slide to help you out. And that concludes our video.